So hello everyone. In this video, we are going to discuss about summations. So consider again the example in the previous videos wherein we tried to count the number of ancestors a persons have in different generations. Okay, so and we can represent that in the equation a sub k equals 2 raised to k, where this represents the number of ancestors a person has in the kth generation back. So suppose we want to sum up or total the number of ancestors has for the past 6 generations. So we can represent that in this formula. So we have a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6, wherein a sub 1 refers to the ancestors a person has in the first generation. A sub 2 refers to the ancestors a person has in the second generation, and a sub 3 refers to the number of ancestors a person has in the third generation, and so forth. So we know that a sub 1 will be equal to 2 raised to 1 because in the number of ancestors has in the first generation will be only his parents, right? And then on the second generation, it will be 2 raised to 2 because we will be counting the parents of the mother, the parents of the father. Okay, so that will be equal to 4, and which is equivalent to 2 raised to 2. And then we have the 2 raised to 3 for the third generation for the great grandparents, and so on. So we see a pattern here: 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3, and so on. So this results to 126. It means that a number of ancestors a person has for the past 6 generation will be 126. Okay, so it is convenient to use a shorthand notation to write such sums. So in 1772, the Greek or the French mathematician Joseph Louis Lagrange introduced the capital Greek letter sigma to write the sum in shorthand notation. So it is in the form of this: the sum of a sub k from k equals m to n, where the k varies from 1 to n. Okay, and this may be expanded in the form a sub m. So that is equivalent to the first na value of k plus a sub m plus 1 plus a sub m plus 2 until a sub n, which is considered as where n is the upper limit. So more generally, if m and n, or in m is the lower limit and n is the upper limit, are and integers, and m is less than or equal to n, then the summation from k equal to m to n of a sub k is this equation that was shown. Some other examples, we have the summation of summation from j equals m. So m is the lower limit to n of a sub j. And another example is or actually we can rewrite it in this way. Okay, so whichever is more convenient for you. Again, we can treat it like a for loop. Okay, so I think you are already familiar with programming using loops. So this is in the syntax of C actually. So we have the initialization. The first initialization is sum equals 0. So for int j equals m, j, and we have the restriction j equals or less than n, then j plus plus, and sum plus or equals a plus j. So what it means is, while j, we first set j equals m, so that will be the lower limit, and while j is less than or equal to n, So while we have not reached the end yet, so j will be the index, of the summation, then we will keep on summing up all the values of all the values or all the values in the sequence or all the terms in the sequence. And we keep on incrementing j plus plus until such time that the j reaches n. Okay, so the j again or is this index of the summation, and n is the upper limit. Okay, and m is the lower limit. So let us have some more examples. Suppose we have the initial conditions a sub 0, a sub 1, a sub 2, and a sub 3 with values 2, 3, -2, 1, respectively. And a sub 4, of course, is equal to 0. So let us try to compute each of these summations. So the first one will be the summation from I equals 0 to 4 of a sub I. So what is the index of the summation here? It would be I. Okay, and the lower limit is 0 and 4. So we will keep on summing up all the terms of a sub I until a sub 0 until a sub 4. So this will be the solution of the first summation. So we have, so what you can actually do is just substitute all of the values, okay, all of the values of I until it reaches 4. So we have a sub 0 plus a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. Okay, and given the initial conditions that we have set, a sub 0, a sub 1, a sub 2, a sub 3, and a sub 4 being 2, 3, -2, 1, and 0, substituting that here, this value of the summation is equal to 4. So what about for the second example? Okay, so we have the summation from j equals 0 to 2 of a sub 2j. Okay, so what would be the index of the summation? That would be j. The lower limit is 0, the upper limit is 2, and we have a sub 2j. So we are basically multiplying 2 to index j. Okay, so we have first, if j is equal to 0, so that would result to a sub 2 times 0, which is a sub 0. So if j is equal to 1, that will give us a times 2 times 1, which is equivalent to a sub 2. If j is equal to 2, so that would be a times 2 times 2, which is equivalent to a sub 4. Okay, so a sub 0 is equal to 2, a sub 2 is equal to -2, and the a sub 4 is equal to 0. So the value of the summation is equal to 0. So lastly, we have this example, the summation from k equals 1 to 1 of a sub k. So this will only have one term, a sub 1. Okay, so a sub 1 is equal to 3. So the value of the summation is equal to 3. Okay, so now let us have some more examples or exercises. So try to compute the summations. So the summation of 1 to 3 times 2i minus 1. So, and then the summation of k equals -1 and to 1 of k cubed plus 2. So you can try to do this on your own. And these are the solutions. You can check your solutions later on, whether you have also arrived at the correct answers.